Hello everyone and welcome to our channel Wrong Math. In this video we will be deriving the equation for the derivatives of cosecant x and cosecant inverse x in a very intuitive way. Let us start by considering a unit circle. This circle has a radius of 1 unit. To define cosecant x, let us consider that the radius subtends an angle of x radians. The opposite side is the sine x side and the adjacent side is the cos x side. Then by definition cosecant x is given by hypotenuse divided by the opposite side, which is equal to 1 by sine x. To find the derivative of cosecant x, we would need to find the difference in value between cosecant x and cosecant x plus dx, which gives the change in value of the function cosecant for a small change in the value of angle x. We will look at a geometric approach to find this difference. We can see that using basic rules of geometry, we can show that the opposite side increases by cos x multiplied by dx, and the adjacent side decreases by sine x multiplied by dx. If you are interested in a detailed proof of this, then check out these videos which derive the derivatives of sine x and cos x functions. Now, cosecant x, or 1 by sine x, can be visualized as the number of sine components that can fit inside the hypotenuse. What about cosecant x plus dx? How do we visualize that? Well, just visualizing it is not enough. We have to do it in such a way as to compare it with the cosecant x visualization so that we can find the difference between them clearly. For this, we would need to have the same number of sine x plus dx sides to compare with the cosecant x value. We can notice that since sine x plus dx has an additional part of cos x multiplied by dx, the total value of these parts exceeds 1 by sine x multiplied by cos x times dx, where 1 by sine x is the number of additional parts and cos x times dx is the value of each part. From the figure, we can mathematically represent this with the following equation where 1 by sine x is equal to 1 plus the additional part value divided by sine x plus cos x times dx. We can distribute the left-hand side and rearrange it to get the difference between cosecant x plus dx and cosecant x. To simplify the right-hand side, we would need to observe that the first-order differential terms in the numerator, as well as the denominator, will lead to second-order terms, which are hard to simplify and are negligible. Hence, we can ignore the cos x times dx term in the denominator. By simplifying the remaining terms, we would get the value of d cosecant x to be minus cosecant x times cot x multiplied by dx. To find the derivative, we would need to take the ratio of the functional change to the change in the independent variable, which would give us the equation for the derivative. Hence, we have derived the equation for the cosecant x function using an intuitive approach. Now let us derive the equation for the derivative of cosecant inverse x, as it is closely related to the derivative of cosecant x function. Essentially, the meaning of the derivative of cosecant inverse x is just to find out how much the angle changes for a small change in the value of cosecant function. This is the exact opposite of the derivative of the cosecant function, where we need to find how much the value of the cosecant function changes for a small change in the angle. Since we already know how much the value of the cosecant function changes for a small change in the angle, which is the derivative of cosecant x, all we have to do now is to reverse that relationship to give how much the angle changes for a small change in the value of cosecant function, which is the derivative of cosecant inverse x. In the first step, since the independent variable x represents the cosecant value rather than the angle, we would need to denote all the angle notation in terms of theta rather than x. In the second step, we will denote all the terms in the cosecant derivative in terms of cosecant theta, which is the independent variable and hence denoted as x. Theta can be written as cosecant inverse x, cosecant theta as x, cot theta as square root of x squared minus 1. Finally, in the third step, we will take the reciprocal of the equation to get the derivative of the cosecant inverse function. There you have it, a geometrically intuitive way of deriving the derivative of cosecant x and cosecant inverse x. If you liked the video, then press that like button, share it with your friends, and subscribe for more amazing content.